Hello everyone, this is Rishiraj Paul Chaudhary and my teammate Nirmit Shikhar Karkera are presenting our work on early glaucoma detection using deep learning with multiple datasets of fundus images. Glaucoma is a very major cause of vision loss, which is often goes undiagnosed until it's too late. So there has been multiple research work on an early detection system, but mostly it has been focused on single dataset of images. To ensure a better generalizability and performance across diverse imaging conditions, our model is trained across multiple datasets, and that approach is helping to increase the model's capability and effectiveness by checking the evaluating metrics and real-world clinical scenarios and image datasets. So the datasets consist of three essential ones called ACRIMA, ORICA, and RIM1, where they are categorized into normal 1 or normal 0 or glaucomatous 1. There are multiple pre-processing pipelines. The minimal pipeline has a simple resizing into 224 into cross 224 pixels and a normalization, whereas the enhanced pipeline has a clay method, contrast limited adaptive histogram equalization method to improve the image contrast. Data augmentation techniques such as flipping, small rotations, and brightness adjustments are applied across the dataset. Moving to the model, we use a pre-trained ResNet model called efficient net B0 architecture, where we add a custom classification layer at the end, which has a global average pooling layer, a fully connected layer of 120 units, and a ReLU activation function with a dropout layer, and also final sigmoid output layer, which helps us with the classification. We execute specifically three training loops, first on the Acrima, second on Origa, and third on RIM1 dataset, and fix the training on 25 epochs with early stopping and L2 regularization for a better convergence. We also use the Adam optimizer with a learning rate of 1 into 10 to the power minus 3 and use the binary cross entropy loss function to calculate our loss. Set the batch size to 32 as the dataset is not very huge. We run two experiments specifically. First, checking the effect of preprocessing on the data. While with minimal preprocessing, the curve shows a moderate discrimination ability, indicating a improvement in reducing false positive. Whereas with enhanced preprocessing, it shows a slightly lower and more stable behavior, indicating that enhanced contrast does work, but does need some more fine tuning. If we move to the model performance as depicted by all the evaluation metrics that you can see here, Acrima obviously achieves a very high performance across all metrics, whereas SIM1 has a solid performance, especially in Okarosi curve and specificity, whereas Origa shows lower sensitivity and F1 score, indicating more false negatives. This really validates what we wanted to achieve is that only relying on Acrima won't give us the right results, and calculating the model metrics across multiple data sets instead of relying on a single data set. The table below also clearly shows how the scores come up, which is very different for Origa and Rim1 as compared to Acrima. Finally, moving on to the results and conclusion, we see that the model performance is overwhelmingly high for Acrima with low loss and consistently high accuracy, whereas for Origa and Rim1, we see some signs of overfitting and on the test data specifically. So the efficient net-based architecture does help us improve the glaucoma detection by training across multiple datasets and create a more generalized model. This approach lays the groundwork for a more stable and a non-invasive screening tool in the form of a neural network model. And there can be more further work in multitask learning, multimodal integration to further enhance the clinical capabilities of such early detections neural network models. There are multiple papers that we reference to, but some of the references are here below. Thank you so much.